Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, welcome to our video presentation for CHM 256. Today we are group 14 who would like to present about liquid sampling focusing on drinking water. Before we start, I am glad to introduce our group members, which consists 4 students. The first one is DAYANA AMIRAH, the second ANISHA, and the third one is me, BATRISYIA, and the fourth one is WAJIHUDDIN HARRAZ. In general, liquid sampling is the process of collecting representative samples of water from various sources, such as distribution systems or aquifers for microbiological quality assessment. From that, we would like to highlight our objective, which is to determine the microbiological quality of drinking water. This is because the contaminated water supplies affect public health, not only through pathogens, also from drinking water itself.
Let's first discuss the theory of sampling in analytical chemistry. Let's begin with the question, what is sampling in this context? According to our lecture notes and supported by the work of peer guide, sampling is defined as a process essential to scientific data collection. It's not just a technical step, it's one of the most crucial aspects of any analysis. Peer guide developed a systematic approach to address the problem caused by poor sampling and emphasized that even the best laboratory analysis becomes meaningless if the sample doesn't represent the bulk material. Errors that occur during sampling can lead to misleading or invalid results. In fact, as Benson points out that even advanced fields like chemometrics struggle because they overlook proper sampling. His work, along with Guy's, shows that many scientific results were flawed not due to bad instruments, but because of bad sampling. There are many types of samples, but we'll focus on the 3 most important ones. First, we have gross sample. This is the large initial sample taken directly from the bulk material. For example, as Benson highlights how collecting large heterogeneous samples presents a challenge, and this is exactly what a gross sample refers to. According to Guy, the ultimate goal of correct sampling is to obtain a representative sample, which is the second type. Representative sample is the reduced and processed portion that accurately reflects the characteristic of the whole material. Fun fact, Guy's story was actually developed because traditional sampling methods often fail to produce representative sample, which led to inaccurate and misleading data. Finally, we have the analytical sample, the small final portion that is actually used in the laboratory for analysis. As stated in one example, the proceedings will be used quite specifically as a general introduction to the role of proper sampling within analytical chemistry. This reflects the full process from gross sample to reduced unhomogeneous representative sample, down to the analytical sample used for testing.
Let's move on to sampling liquid. Liquid samples are homogeneous and are much easier to sample. The gross sample can be relatively small, and if the liquid samples are not homogeneous and only have small quantity, they can be shaken and sampled immediately. Sampling will be depending on the types of liquid. There are 3 types of liquid. For the first one, large volume of liquids, which is impossible to mix. It is a type of liquid when it's in a pipe after passing through a pump where they have undergone the most rough mixing. For the second one, large stationary liquids, which is from lakes and rivers. For this type of liquid, we'll be using TIFF sampler, which is a device for obtaining aliquots at different levels. And for the last one, biological fluids. The timing of sampling biological fluids is very important because of the blood composition varies before and after meals. So, liquids mixed by diffusion is slowly and must be shaken to obtain a homogeneous mixture. If water sample is taken from the river, then the water samples is collected at the surface, middle, and at the bottom of the riverbed. If liquid is in a large container, the liquid should be stirred first before the samples are taken at the top, middle, and at the bottom of the container.
Now let's move on to our method of sampling drinking water. First, we have to clearly label the sample bottle. Second, turn the tape full on and allow the water to run. To waste 2 to 3 minutes is generally sufficient. This flushes the entry of the nozzle and discharges stagnant water. Disinfect the tape using the disinfection by flaming method as outlined below. For household plastic taps or where flaming is not possible, use the described method for disinfection where flaming is not possible. Fourth, following disinfection, the tape should be opened. Adjust the flow to deliver a gentle stream of water. Hold the bottle. And fifth, we have the hold the bottle in one hand. Remove the screw cap with the other and keep in your hand with the open side down. 6. Fill the bottle almost to the top, leaving a sufficient gap to allow for mixing by the laboratory. Carefully replace the cap. And lastly, we have store and transport in accordance with sample transportation. Now, let me explain about this disinfection by flaming. Flaming is the preferred method of disinfection and is suitable for metal taps. After flushing, turn off the tip and sterile the spout by flaming with a butane or propane burner. Begin at the nozzle and work back towards the body of the tip until the water held in the nozzle boils. Lighters or metallite spirits do not generate sufficient heat and should not be used. Open the tape to half flow and run to waste until a constant temperature is reached. Now, I will explain about disinfection where flaming is not possible. For disinfection of household plastic tips where flaming is not suitable or where an open flame cannot be used, the following alternative can be used for disinfection. Sodium hypochlorite solution, freshly made up to 1 gram or per liter free chlorine, ethanol or isopropanol 70% volume per volume. After flushing, turn off the tip and dip in a solution of hypochlorite, ethanol or isopropanol for 2 to 3 minutes. Alternatively, a sweat spray or wash water may be used to disinfect the outside and as much of the inside as possible, waiting 2 to 3 minutes for the solution to take effect before turning the tape on again. Take caution using sodium hypochlorite as it is a strong oxidizing agent and is highly corrosive. Now let's move on to our example of sampling drinking water. On 50 June 2025 at 10 a.m., a water sample was collected from a household kitchen tap located at number 20 Jalan Kenari, Selangor. The objective of this sampling was to obtain a representative water sample for laboratory analysis, specifically to test for bacterial contamination. The material used during the sampling process include a sterile 250 ml sampling bottle provided by the laboratory. Clean glove to maintain hygiene and avoid contamination, a permanent marker for proper labeling, and an ice box with ice packs to preserve the sample during transport. All necessary precautions and procedure were followed to ensure the integrity and accuracy of the sample for testing. Now let's move on to our second situation. For example, sampling drinking water. As part of the annual water quality monitoring, residential sites project, a drinking water sample was collected by Jane Smith on June 14, 2025 at 9:50 a.m. The sample was taken from the kitchen sink's cold tap at 123 Maple Street. The purpose of the sampling was for bacteriological analysis, specifically to test for the presence of E. coli and total coliform bacteria. The sample labeled with ID 2025 Maple 001 was collected using a sterile 250 ml sampling bottle containing sodium thiosulfate to neutralize any residual chlorine. Prior to collection, the aerator was removed and the tapes was flushed for 5 minutes to ensure a representative sample. The sample was stored and transported in a cooler with ice packs and delivered to Clearwater Environmental Labs by 11:30 a.m. At the time of delivery, the sample temperature was maintained at 4 Celsius. The lab recorded the sample under lab sample number CWL 354221 and no preservation was required beyond refrigeration. In conclusion, proper liquid sampling of drinking water is crucial to ensure accurate and reliable analysis of contaminants or chemical composition. It requires clean, appropriate containers, proper preservation methods, and adherence to standardized procedure to avoid contamination or degradation. A well-executed sampling process support public health by ensuring the safety and quality of drinking water. This is all the reference that we have used. Thank you. Bye.